Good afternoon, ladies and gentlemen. Hope you enjoyed your lunch and you're not too tired yet. My name is Udo Steinecker. I'm working for Cable and Wireless within the engineering group, both in the public AS1273 part, as well as in the so-called private AS4445 network, which is the MPLS VPN network. So let's start. This talk is about how to connect one service provider's MPLS network within together with another service provider's network. These networks are designed to be interconnected according to the REC 2547 BIS, which is layer 3 VPNs. No public internet stuff and yeah, stuff like that. Okay. Sorry. Okay. This presentation is divided into two major parts. A general section, which is just a short review, how what the methods are from a technical perspective according to the REC 2547. And the second part is just how CW has done that with other service providers, and a short report what problems we had once we have done that the first time, and the considerations we have found that are necessary to think of once ISPs think of doing the interconnections, and a very, very short look into the future on what is going on in the IETF meetings. But this is just then a short report on what I personally found very interesting. So let's start with the first part, the general section, what the different methods of interconnections. Okay, this is the agenda once again. Sorry. Yeah, I've talked so. Okay. The first method is two ISPs connect their networks with neighboring PE routers, and they are connected via lease lines, POSes, Ethernets, ATM, whatsoever, probably POSes. And the first possibility is to use an back-to-back VRF on the connected interfaces, which leads to every VPN that needs to be extended to the neighboring AS will be configured as a sub-interface of the two PEs, and each sub-interface will reside then in a certain VRF, which is then customer 1, customer 2, customer 3, customer 4, and so on. Do I miss something? Yeah, I think this possibility is pretty much known, and everyone interested has read that stuff so far. The disadvantages is that from an operational point of view, the configs tend to grow very large, and the troubleshooting section is pretty annoying then for the operational folks, so we didn't decide to do that one. The bad coloring. Yeah, the second method is a little different. Again, we have the two neighboring PE routers, and they do not exchange the labeled BGP prefixes from the certain VRFs, from the different VRFs, but they exchange only the /32 loopback IPs from all the PEs of the neighboring ISPs. And the PE routers, where the customers are connected on both ends, just do multi-hop eBGP sessions. Yeah, so far, so good. Yeah, I got the point with the multi-hop eBGP sessions. And the third possibility is that, again, the two PE devices now exchange the labeled IPVPN-v4 prefixes of the certain VRFs based on route targets and the matching route distinguishers. So compared to the possibility before, we don't exchange the loopbacks of all the customer connected PEs, but we only exchange these label prefixes that are really that only are needed to between the two service providers. Based on the route targets, it is possible to filter based on the route targets and route distinguishers and so on. But we come to that point a little bit later. I think, yeah, these were the three possibilities. I think this is clear so far. Any questions here? No? Okay. Okay, now the point, what we have chosen and why. Just to make sure, once again, CW operates two different networks. The one is AES-1273, the public IP network, which is, you know, internet. And on that network, we don't operate MPLS VPNs. For MPLS VPNs, layer 3 VPNs, we have built and operate a different network, which is run under AES-5554, which is at the very moment running only layer 3 VPNs according to RFC 2547. And the interconnection method we have chosen with other service providers was the third option, just to make sure which one that was. The two neighboring PEs exchange the labeled IPv4 VPN prefixes based on route targets and route distinguishers. Oops, I had more. Yeah, this is not the current slide. The more descriptions here was the stuff from before. Oops. I think we have to change there. This is not the latest one, but there's no problem there. Okay. Just 1 second. Okay.
Do you think you have a video going anywhere close?
Huh? Doesn't it bring anything? Okay, just 1 second. Okay, here we go. Sorry for a short break. Okay, sorry for the short break. Yeah, so the last point was what method we have chosen. Again, this is the third method, exchanging the labeled IPVPN v4 prefixes based on the route targets and route distinguishers. So our network looks like this. We have 4 regions which are confederated under one AS 445. And we have a UK region which is using a private AS, an US and European and an Asian Pacific region. The regions are either directly connected or other regions are transit regions, like for the Asian Pacific region. There's the main route going through the US region, and there's a backup route through the UK region. Okay. So once we first have decided to do interconnections with other carriers that have greater carriers that have more locations in areas where we don't have POPs also. We thought it is needed to connect with them, and once we went into the test stage in the labs, we found different points, bits and pieces that are critical or at least good to think of, and we found that one of those, and I'm going through all these points, and the first one are the route distinguisher values. Okay, here we go. The route distinguisher is an 8-byte field that is prepended to every IP prefix. The IP prefix then and the route distinguisher together make the unique IPVPN v4 prefix. So within our AS, we take the form 4445, which is the AS number, and then unique decimal numbers like from 1 to somewhere else. One important point here is once the first interconnection has been done, we run into the trouble that the RD values didn't match. So the neighboring service provider had different values than we had, and we ran into routing problems, which were memory usage. The consumption was pretty high, and we had at least duplicate prefixes going around both networks, and we tried to overcome that. Yeah, this is actually at this slide. Yeah. Once we have different route distinguishers that are exported from both ends or from both ISPs, they are valid in both clouds, but the implications are that every prefix is at least two times there, one with service provider 1's RD and one with the service provider 2's RD, and they don't match, and very funny problems arise then. So it is very crucial that the service providers agree on the same route distinguishers for one certain VPN or customer or VRF, as you want to call it. Yeah, they should be the same on both ends. Okay. Yeah, as I told before, they should be the same. Yeah, one operational issue is here. There are some tools around that can be either bought or self-written from or freeware. Some provisioning tools use hard-coded route distinguishers, like you add a new customer to the system, so they increase the last route distinguisher by 1, and this makes the automatic provisioning of a new customer to the VPN network a little bit hard. So manual intervention is probably not what's the right word? Yeah, you cannot avoid manual intervention there. Okay. Basically, the same applies for the route targets. The route targets is an extended BGP community that is used within the address families IPVPN v4 family, and it is used to determine whether a prefix is accepted by another PE or not. So filtering, yeah, an interesting point of route targets is here. I've had the slide before, which was this one. Yeah, we do filtering of traffic from one area to another based on the route targets. That means once we have customers that are only there in the US region, we don't propagate the VPN routes to the other region unless the customer hasn't got a site, unless the customer has a site there. So we need to leak them, in that case, between the regions. But otherwise, we do not export the routes to the other regions just to save memory and yeah, stuff like that. So back to the route targets. The numbering scheme is again the same. We use on the left-hand side 4445, and then again again decimal numbers. So again, the route targets should be negotiated between the two service providers, because this makes the filtering of unwanted prefixes easier. And one could say that why not rewriting the targets on the two neighboring border router PEs where the two service providers meet? Yeah, basically it would be possible. But we didn't do that for several reasons. One was that it is possible to rewrite the route target, but rewriting the distinguisher wasn't possible, and the manipulation is only doable on the import side, not on the export side. So again, the last point here is once you connect with another service provider, make sure that both ends try to have, make sure both service providers use the same route target for each VPN they want to exchange. Okay. Yeah, this is just a short description why we have done that and what the implications are. I have to admit this slide wasn't by me, so I had a hard time to get around it. And yeah, to explain that is a little bit odd for me right now, so I can't say too much here. I'm sorry. Yeah. Is this so far clear? Yes? No? Hope so. Okay. An important point to think of is also that each service provider has a different quality of service model, having different service classes. One has 3, bronze, silver, gold, while others have 4 or 5. And one point is here that there's a need to do a mapping of one model from service provider A to the model of service provider B, unless the customers would be treated unfair in the way that the maybe better cross model or service class silver from service provider A is in service provider B something a little bit worse, but also called silver. So there's a need to map these service classes, and this and there are only 2 points where this is important. On the ingress PE, where the customer traffic gets labeled and queued, and also on the egress PE between the 2 service providers. And yeah, and yeah, this is the interest. So here's a little example how this mapping could be done. The implication of that is that the PE router must support the other service providers cross model. Yeah, as I told you before. And yes, yeah, I think I've told that before. Here's just the slide that describes it a little bit better. Okay. I've told that. Yeah. I think, yeah, this slide is just what I've told you before. I just changed the slides, not in time. My bad. Okay. Okay, here's an example how this could work with the customers label. No, I'm sorry. A little bit nervous. We need to ensure that service providers 1, gold and silver, and so on, service classes are mapped with our classes that can be named different. And we want to avoid unfair treatment of the customers either on our side or on the other side. And so we do the mapping of the EXP bits, which are then the DSCP values so far. The manipulation, as I said before, can only be done on the ingress side, which is either the customer side, where the PE where the customer is connected, or the PE where the 2 service providers have their connections. And both service providers are responsible to know the other service providers' values or classes and to map them accordingly. The mapping, unfortunately, is done totally on a manual basis with the hope that the other service provider doesn't change their cross model without telling all their neighboring ISPs. So, okay. Another point is resilience. Like in the public IP network, we want to avoid just having one link with a neighboring ISP. So having multiple peering sites or interconnection sites, and having multiple points where we connect with other service providers. Bless you. We have the same issues like Randy had in his presentation before with suboptimal routing or asymmetric routing or stuff like that. Just as a side note, this asymmetric or suboptimal routing can lead to influence the service level agreements, and it is easy to break the the values that we have promised our customers. So we try to avoid either asymmetric routing or suboptimal routing, and there are ways to do that, and we all know it from Phil Smith's BGP introduction yesterday, using MEDs, using local prefs and stuff like that. Yeah, MEDs, local prefs, or even the standard communities, given that both ISPs, A, don't filter standard communities, and B, accept them and transport them through their own network so far. Okay. Security is even there an issue. One would say that MPLS-based VPNs, once they are built on in a separate network, are not faced to threats from the internet because they are not reachable from the outside world. But there are still some issues. We have the 2 points between the PEs, between the service providers, and even the CE routers, CE to PE connection. So we want to avoid. Okay. 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 So I have to hurry up a little bit. Sorry. Okay. Okay. So these are the major 2 points where we want to make sure that the devices cannot be taken over by someone else, or when the customer even has a breakout through the VPN to the connected. No, sorry. We offer an internet breakout through the VPN to the global 1273 network, and we want to ensure that all the internet breakout traffic is going through firewalls and no one sees the CE to PE links from the outside world, and we want to avoid that no one sees the PE to PE links outside the world. So there are different methods. On the CEs, we could use standard ACLs and... I'm sorry? Okay. Okay, so these are the major 2 points we have identified as security concern points. Okay, stuff that we consider to test or implement soon. We want to support supporting carrier stuff. This is currently in a test stage right now. We want to use a little bit of the OAM stuff, which is currently going on within the IETF, and we're looking forward to see something from the vendors. And draft Martini Layer 2 VPNs, which we do not have right now, but this is something that is being implemented I would say in September this year. And the last side, the future stuff, which I think is pretty interesting from the IETF side, is inside the working group PWE3. This is the pseudo-wire edge-to-edge emulation, which covers currently point-to-point links, and then the VCCB stuff, which also covers point-to-multipoint links. Okay, this is from the IETF side, yeah, what I think was the interesting part, most interesting part. So if there are any questions, either write a mail so I have time to think about it, or even outside, because we're really short on time. Get me a beer later and ask there. Thank you. Are there any questions?